2.2. Solving equations with the multiplication property. Section 2.1 talked about solving equations with the addition property. This section, 2.2, is very similar. In 2.1, we talked about the key goal, getting the variable all by itself on one side of the equation. We did that by performing the opposite operation and undoing what was attached to the variable. In this section, we will do the same procedure, but we'll use the operations of multiplication and division. Let's say that you had the equation 6x is equal to 30. In this particular equation, we have 6 multiplied by x, and we want to get rid of that multiplication of 6. So I'm going to undo the multiplication of 6, and I'm going to divide it by 6. Whatever I do to one side, I have to do to the other side. So I'm also going to divide 30 by 6. Now, the 6 divided by 6 is equal to 1. So that just cancels out. On the left-hand side, I'm just left with x. On the right-hand side, 30 divided by 6 is equal to 5. Once again, just like in the last section, I can go through and make sure my answer makes sense by putting the answer back into the original equation. And certainly, 6 times 5 does equal 30. Here are two more examples. If you are given negative 3x is equal to 27, you're going to do exactly the same thing. Just remember that now I need to divide by a negative 3 because I'm multiplying negative 3 times x. To get rid of that negative 3, I have to divide by negative 3. Whatever I do to one side, I have to do to the other side. The negative 3 divided by negative 3 cancels out, just leaving me with an x. And 27 divided by negative 3 is equal to negative 9, which is the answer. Sometimes when you're doing it, you might not get an integer answer or a whole number answer. And here's an example. 8x is equal to 5. I'm going to do exactly the same procedure. I'm going to divide both sides by 8. On the left-hand side, 8 divided by 8 gives me 1. I'm just left with an answer of 5/8. Here's another example, this time with a fraction. If you have 4/5 x is equal to 8, you can go through and you follow the same procedure. I have 4/5 times x. So what I'm going to do is I'm going to divide that by 4/5. If I divide the left-hand side by 4/5, that also means that I need to divide the 8 by 4/5. So I would divide 8 divided by 4/5. On the left-hand side, 4/5 divided by 4/5 is just going to give me my x. And on the right-hand side, I have 8 divided by 4/5. Remember, whenever you divide with fractions, you always change it to a multiplication problem and flip-flop that second number. So if I wanted to find the answer for that, I'm going to go 8 over 1 times, instead of 4/5, it would be 5/4. And then I could go through and multiply across. 8 times 5 gives me 40. 1 times 4 gives me 4, for a final answer of 10. So I know that x is equal to 10. But I want you to notice something. Notice that what I did is I multiplied by 5/4. When I divided by 4/5, up here, it was exactly the same thing as multiplying by 5/4. So really, when you have a problem like this, and you want to solve it, have 4/5 x is equal to 8. Another way to go through and solve this is to just know that the reciprocal of 4/5 is 5/4. So in this particular case, I could have said, well, I'm going to multiply this side by 5/4, and I'm going to multiply this side by 5/4. If I multiply the left-hand side by 5/4, that cancels. I'm just left with the x. And then the other side, I still have that 8/1 times 5/4. Now, the first time I did it, I multiplied straight across. I do want to remind you that another way to do this is to do that canceling. 4 goes into 4 once, 4 goes into 8 2 times, and then I can multiply across. 2 times 5 gives me 10. 1 times 1 gives me 1. I still get an answer of 10, and you can solve the problem that way as well. Here's another example of the same type of problem. If I have 3/4 x is equal to a negative 15, this time, rather than dividing both sides by 3/4, I'm going to multiply both sides by the reciprocal of 3/4, which is 4/3. If I multiply the left-hand side by 4/3, I have to multiply the right-hand side by 4/3. On the left-hand side, 4/3 times 3/4 is just equal to 1, so I'm left with x. On the right-hand side, I have negative 15/1 times 4/3. Once again, I can go through the canceling process here. 3 goes into 3 one time, 3 goes into negative 15, negative 5 times. Then I can multiply across. Negative 5 times 4 gives me a negative 20, and it is negative 20/1, so the final answer is just negative 20. Sometimes in this section, you may have two x terms on the same side, and here is an example of what I'm talking about. If I had 5x plus 4x is equal to 36, before I am going to do anything to get rid of the 5 or get rid of the 4, I can combine those terms, because 5x plus 4x is actually equal to 9x. So if you can combine any like terms on a particular side of the equation, make sure you do that first. So now I have 9x is equal to 36, and now since I'm multiplying x by 9, I'm going to divide both sides by 9. When I do that, I get a final answer of x is equal to 4. How about if instead of multiplication, you are dealing with division? For instance, if I have x divided by 6 is equal to 3. Because now I'm dividing x by 6, I'm going to do the opposite of dividing, which is multiplication. So now I am going to multiply both sides by 6. So on the left-hand side, I'm showing that 6 times x over 6 is equal to 3 times 6. I had divided x divided by 6, and now I'm multiplying by 6. So those cancel out. I'm just left with x on the left-hand side. 3 times 6 is equal to 18, which is the final answer. I can go back up, put 18 back in the original equation, and I do see that 18 divided by 6 is equal to 3, so I do have the correct answer. Here is one more final example. Negative x divided by 8 is equal to a negative 3. Since it's dividing by 8, I am now going to multiply both sides by 8, and I'm going to show that in this next step. The 8 and the 8 cancel each other out, so I'm left with a negative x is equal to a negative 24. Remember though, we are trying to solve this for x, not for a negative x. And there's an understood 1 in front of that x. So it really is negative 1x is equal to a negative 24. In order to solve that for just x, I am going to go through and divide by a -1, because the -1 divided by -1 gives me a +1, or I'm just left with x. If I divide the left-hand side by a -1, I also have to divide the right-hand side by a -1. So -24 divided by -1 gives me a +24. Once again, going back up to the original equation, if I put 24 in for that, x, I'm actually going to have -24 over 8 because of this negative sign here. -24 divided by 8 does give me -3, which is what I needed. So this does check, and the answer is 24. I think you'll find the exercises found in your book under section 2.2 are very similar to the problems that I've gone through in this video. Thank you.